Hello everyone. So today question is that you are given a binary array. Your task is to find number of swaps required to bring all ones together anywhere in the array. So let's say we have an array, and what is binary array? An array consists of either 0 or 1. So let's say that this is my binary array, and now I have to group these two ones together. So either we can group them in this way, or we can group them in this way, or we can group them in this way also. Okay, so for doing this configuration, we need one swaps. How we can swap this 0 with 1? For this configuration, we need two swaps. How? First, we will swap this 1 and 0, so it will become 1 0 0 1. Then again I will swap this 0 with this one, so it will become 1 1 0 0. Okay, so here we require two swaps. For this configuration, we just need one swap, and we can do swap with this one with this 0. Okay, so here we need only one swaps. So in the question, they are asking that how many minimum number of swaps we need to require to group all the ones together. Okay, so let's take one more example. So let's say that I have an array, and the array consists of 0 0 1 0. So here we need 0 swaps. Why? Because there is only 1 1 and it is already grouped together. Okay, let's take one more example. So this is my array. Okay, now we need to group all the ones together. Okay, so the easiest way is that we will swap this 0 with this one, and in one swap we have group all the ones together. Okay, so how we are going to approach this problem? So one way is to think in that way, that first let's count how many 1 is present in this array. So let's say k represent how many 1 we have in this array. So here we have 3 ones. Okay, now what I need in this array, I want a subarray of size k, where I can fit this we can group all this one together. Okay, so what is the best or optimal window we will find inside this array, so that we need to do minimum swap. So think in a way that if we find a k subarray such that it contain maximum 1. So here, since the value of k equal to 3, so I need a window of size 3 which will have maximum ones. So one window is this 3 element. So here the number of 1 is only 1. So if we choose this window, so I need to do two swap. Okay, so I need to replace this 2 0. Okay, so again, if I choose this window, so again since there are 2 0, I need to do two swap again. If I choose this window, so here I will have only 1 0. So again, in this scenario also we need only one swap, or we can choose this window. Okay, in this window also we have only 1 0, so we need only one swap. Okay, so ultimately our approach is, we need to find a optimal k size window where k represent the number of ones in our array, so that we can replace that 0 with 1. Okay, so let's take one more example. So is the array equal to 1 0 1 0 1 0 0 1 1 0 1. So here k equal to 6, right? Now I need to find a k size window where which will have maximum ones, right? So one option is that if we start from here, we have this window, right? Here the window size is 6 and the number of 1 is 3, right? So here if we replace this 30, we swap this 30 with this 3 ones, so we need 3 swaps, right? Is there any other optimal solution? So maximum, again, if I need to have maximum 3 ones, so this is also one window, right, where we have 3 ones, right? But again we need to replace 30 from this window, so our output is 3. So our finally how we are going to calculate our minimum swaps? So minimum swaps is equal to total ones in the array minus max ones in any window of size k. Okay, so let's go and see the code part. Okay, now that we understand the intuition, let's write the optimized code using a sliding window approach. Okay, so we have defined a function called minSwap and we are passing the array called as data. Now what we will do first, we will first find out how many total ones is present in our array. So what we will do, we will just sum the data, because our data is a binary array. Okay, so either it will have 0 or 1. Then we will define other variable. So the one variable is max ones in window. So what this max ones in window do? It will keep track of max number of ones we have seen in any window. So already we have defined that while creating the window, we will keep track of number of ones we have seen. Okay, similarly we will have one window start. What will window start do? Window start is the left pointer of our sliding window. Okay, and we will initialize it from 0. Similarly we have current ones. So what this current ones will do? So current ones will track how many ones are currently in the window. Again we will initialize it with 0. Now we will loop through the array. So for window end, this is my right pointer basically, which will expand basically in range of data. And every time we will increase the current ones. So why I am increasing the current one? Because for every element we add to the window. If it is 1, we increase current ones. Okay. And if it will 0, then it is not going to increase. Okay. And if at any point, if we find that if my window end minus window start plus 1 is greater than total ones, what this line mean? This line is saying that if there are total k ones present in the array, so we need to find a optimal window of size k. So if the window size will become greater than total ones, what we will need to do? We need to shrink the window. And how we are going to shrink the window? We will decrease the current ones from the window start. Okay, so we will decrease our current ones from the start. minus data of window start, and we will increment our window start. Okay, so if the window become larger than the required size, then we shrink it from the left by subtracting the leftmost value and moving window start forward. Okay, this is what this code is telling. And finally, after the if statement, we will have max ones in window, which will be max of max one in window, comma the current one. Okay, and finally we have to return the total ones minus max ones in window. Let's take an array, data equal to 1 0 1 0 1. So first we are calculating total ones, which is equal to sum of data, and it is equal to 3. So we need to find what this total ones saying. This is saying that we need to find a window of size 3, because we need to group 3 ones together that already contain the maximum number of ones, right? Then again we are going to have variable window start 0, and current ones is also 0, and max one in window as 0. This is what we are initializing here. Okay, and after that let's do the dry run. So if I equal to 0, our data of 0 equal to 1, so my current ones equal to 1, right? And my window size will become I minus window start plus 1. So it is 1, right? And it is less than 3, because here the checking condition is that if window end minus window start plus 1 should be greater than total count, then total ones, then we are going inside this loop. But it's not satisfying this condition here, so we will not go inside this if condition. Okay, now let's, and again we are updating at I equal to 0. We will update our max ones in window, which is equal to 1 here, right? Similarly for I equal to 1, data of 1 equal to 0. So here current ones plus equal to 0. So my current ones will be 1 only, and but my window size is 2 now, but again it is still less than 3, and my max ones in window is still 1. Okay, now again for I equal to 2, my data of 2 equal to 1, my current ones I am adding 1 in it, so it will become 2. Now here my window size equal to 3. Okay, and my max one in window equal to 2 now, because we have 2 ones in my window now, right? Again for I equal to 3, data of 3 equal to 0. So current one will become 2 only, right? And then my window size equal to 4, which is greater than 3. So we are now inside this if loop, right? We are inside this loop. So what we are going to do, we are shrinking from the left hand side, right? So how we are going to shrink? We will subtract data of 0 Okay, so what we were doing, we were subtracting my data of 0 from current one, right? So after subtracting data of 0, since data of 0 equal to 1s and my current ones equal to 2, so now my current ones will be equal to 1 only. Okay, and now we will move window start to 1. So since I am shrinking the window now, my window start will become 1, right? And here my max ones in window equal to 2 only, because what max ones in the window say, max one in window says how many maximum ones we have seen so far in any window. Okay, and finally for I equal to 4, data of 4 equal to 1, so my current ones equal to 2, and my window size is again become 4. So we need to, which is greater than 3, so we need to shrink the window again. So here, how we are going to shrink? My window start was on 1, so we will subtract data 1 from the current ones, but since the data 1 is 0, so my current ones equal to 2, and my window start will become 2 now. I will increment the window, and my max ones in window equal to 2. Okay, and after this loop end, we just need to find the min swaps. So min swaps equal to total ones, which is 3, minus max ones in window, which is 2, right? So it will become 1. We need only 1 swap. Okay, so I hope you like this video. If you have any suggestion or feedback, please comment in the channel. Okay, thank you. Have a nice day.